Hello students, I am Anurag Gupta, MBA Finance, a topper of University Department Pune, and I am also a CFA from ICFAI University. After spending a few years in financial sector, I left a lucrative corporate career to pursue my passion for teaching. I have been a top ranker in various exams at school, college, university, and even at all India level. And I have consistently produced top rankers from my institute for the past 8 years. And here I must mention that many of my students who were average performers till their standard 10 exams showed excellent results in their standard 11 and standard 12 exams, and even now they are doing really well in their respective careers. Now, with a view to spread my knowledge to the maximum possible students, I have started teaching in online mode as well. Initially, I will bring videos on maths, accounts, economics for the students of class 11 and 12, where I'll cover the entire syllabus in a very systematic way. I'm sure you'll enjoy the process of learning in my lectures. So, welcome to my channel. Hello students, this is my second video on this topic, linear inequalities. In the first video, I have already covered the meaning of inequality, and it is actually a very important video because I have covered the concept in great detail, and I have covered part of exercise 6.1. The questions which belong to a particular type I have covered, and today in this lecture I will cover the remaining part of exercise 6.1. So in the previous lecture I had told you to solve the inequalities, how we solve the rules for solving inequalities, and how to derive the solution set. Once we have derived the solution or solution set, then that was algebraic solution, and now we are talking about graphical solution or number line solution, how we represent the solution on a number line. So that now see, for example, I'll take question number 17 and 18 from exercise 6.1. Take this question, 3x minus 2 is less than 2x plus 1. So we will solve it in a normal way. We will take 2x on the LHS, 3x minus 2x is less than, we will take 2 to the right hand side, and so what we get is x less than 3. Now here we just have to learn how to represent this on number line. It's very simple, x less than 3. Right, here we assume it is all a real number, x is a real number. So this is real number line, and when we show this, we make it a little dark. This number line, whatever represents a solution, we'll mark it like this: 0, 1, 2, 3, 4, and 0, minus 1, minus 2, minus 3. So to the left of 3, that means less than 3, we will make the line a little dark, and we will make a circle at 3. Why this circle? We will not shade or color this circle because 3 is excluded. This is not x less than equal to 3, it is simply x is less than 3. So here we have excluded 3. When we are excluding 3, we will show it as a circle. We will not darken it. And the remaining line we will darken. So this portion shows the solution of this particular inequality. Now in question number 18, this is showing greater than equal to sign. So when we solve this, we get 2x is greater than equal to minus 2, or finally x is greater than equal to minus 1. So when it is greater than equal to minus 1, so once we draw a number line and we mark the numbers on it, then we will show the right side of minus 1, and we will darken this circle because here minus 1 is also included in the solution set. This is the only difference, and this is a very easy concept. In this exercise, the remaining questions pertain to this concept and the word problems. In word problems, we will make an inequality and then we will solve it. So let us move to our exercise 6.1. The remaining questions, let us solve the remaining questions. So we have seen these two questions, 17 and 18. And this one more thing I would like to mention, on the number line, we can show the solution like this: x is less than 3, and here x is greater than equal to minus 1. Now, question 19 is a similar question, so we'll skip it and we'll move on to question number 20. Here the only difference is it gives a fractional value in the end. So let us see this. If it is given x by 2 is greater than or equal to 5 into 5x minus 2 minus 3 7x minus 3 whole upon 15, if we simplify it, it will come to this, and finally the value will be x is greater than or equal to minus 2 by 7. So on the number line we will represent it like this. We will show it between 0 and minus 1. We will show a value minus 2 by 7, and then from here we will darken the line and a dark circle we will make here, because it's greater than equal to, not just greater than, it is greater than equal to, and we will show the solution here. So this is a very simple concept, graphical representation of solution of inequality. This is how we'll do it, and let us move to the next concept. These are the word problem. Again, here the main task is to formulate an equation, and in equation first we have to form, and then solving is the easy part. We have been doing this in the other questions in the exercise. The main task is to understand the question and to form an inequality. Let us see how. See, the first question is Ravi obtained 70 and 75 marks in first 2 unit tests. Find the minimum marks he should get in the third test to have an average of at least 60 marks. So we have to find the minimum marks. Now find the minimum marks when it's given. So let us start from here. Let x be the minimum marks required. And then we'll make an equation like this. The 70 and 75 are the marks in the first 2 unit tests. So we will add them up, 70 plus 75, and we will add this x, because in the 3 test he should get, on an average he should get 60 marks. So how do we find the average? We will add up the 3 marks and we'll divide by 3. So 70 plus 75 plus x upon 3. This should be greater than or equal to, this is the main thing here. It has to be at least 60 marks. That means more than, equal to 60 or more than 60 marks. The average has to be more than 60. So it has to be, this average has to be greater than or equal to 60. Minimum it should be 60. It should be 60 or more. But now once we have derived this, then it's very simple. It is a usual steps from here. 145 plus x, this is how we'll make it. And this 3 goes to the RHS. 145 plus x is greater than or equal to 180. X is greater than or equal to 180 minus 145, or x is greater than or equal to 35. Thus, Ravi must obtain a minimum of 35 marks to get an average of at least 60 marks. So this was the main task. Once this is achieved, the remaining becomes very simple. Now, the next one is, to receive grade A in course, one must obtain an average of 90 marks or more in 5 examination. Again, this one is an important information. Each of 100 marks. If Sunita's marks in first 4 examinations are 87, 92, 94 and 95, find the minimum marks Sunita must obtain in the 5th examination. It's very similar to the previous question. Marks in 4 exams are given and average marks are given to be 90, and we have to find exactly the same as this question. Here only there were 3 unit tests. Here there are 5 subjects. So the marks of 4 are known and the average is known. What are we required to find? We have to find out Sunita's marks in 5th examination so that she can get grade A in the course. So let x be the required marks. Then we'll add up these 5 marks, and here we have to add x upon 5 because average marks is being talked about, is greater than or equal to 90. This implies then we have to solve this and we come to the final solution as x is greater than or equal to 82. Thus Sunita must secure minimum of 82 marks. Next question is, find all pairs of consecutive odd positive
integers, consecutive, odd, positive integers, both of which are smaller than 10. First condition is both will have to be smaller than 10 such that their sum is more than. So first condition is both the numbers have to be smaller than 10, and the second condition is their sum has to be more than 11. These two conditions we have to take care of. So let us take x as a smaller number. There are two consecutive numbers, so we will take x as a smaller number and the other will be obviously x plus 2. Now the second condition is, the first condition is obviously x has to be less than 10, and the second condition is that the sum of these two numbers has to be greater than 11. So it will be 2x plus 2 greater than 11, and finally we come at the solution as x is greater than 9 by 2 or 4.5. Now which is a number which is greater than 4.5 and it is an odd number? The number is 5. If we get first number as 5, then this next number will be 7. 5 plus 2, 7. So with this we get the first pair. First pair is 5 and 7. What can be the second pair? Second pair after 5, the next odd number is 7. So the second pair will be 7, 9. Now there are only these two possible pair. Why is it that there is no other possible pair? Because if we take now 9, then the other number will be 11, which is not possible. The condition is both the numbers have to be less than 10. So if we take 9, the other number will be 11. So we cannot take that pair. So the only two pairs available are 5, 7 and 7, 9. Hence the possible pairs are 5, 7 and 7, 9. The main thing is this, how we come at an inequality. How we form an inequality. That is the main step in any question. After that, it becomes very simple. Now, the next is find all pairs of consecutive even positive numbers. Now, here it is consecutive even positive integers. Both instead of odd, it is even. That's the only difference till this place from the previous question. Both of which are larger than 5. Here the first condition is both of which are larger than 5. Such that their sum is less than 23. Almost similar to the previous question with minor variations. Let us see how we do it. Let x be the smaller number, other will be x plus 2. Then the second condition is x plus 2 is less than 23. This if we solve, we get x is less than 21 upon 2 or 10.5. Now what are the values that x can take? Because the first condition is both of the numbers have to be larger than 5. So larger than 5 and less than 10.5. Here we have arrived at a solution that as x has to be less than 10.5. But it is also given that the numbers have to be larger than 5. So larger than 5, greater than 5 and less than 10.5. What are the possible numbers? So x can take values 6, 8 and 10. Now we have got first numbers of the pairs, and so the second numbers will be x plus 2. That means we add 2 to 6, we add 2 to 8 and we add 2 to 10. So we get the first pair as 6, 8, second pair as 8, 10 and the third pair is 10, 12. Hence the possible pairs are 6, 8, 8, 10 and 10, 12. Now let's see the next question. The longest side of a triangle is 3 times the shortest side and the third side is 2 centimeters shorter than the longest side. So if the perimeter of the triangle is at least, here we have got a clue, at least 61 centimeter, find the minimum length of the shortest, minimum length we have to find of the shortest side. So let the shortest side be x, then the longest side will be 3x because the longest side of the triangle is 3 times the shortest. If the shortest side is x, then the longest side will be 3x. And the third side it is given is 2 centimeters shorter than the longest side. So if the longest side is 3x, the third side will be 3x minus 2. So now it's very easy to make the inequality x plus 3x, the sum of the three sides, which is nothing but the perimeter of the triangle. So the sum of three sides has to be greater than equal to 61 because it is given at least 61. So it has to be, the sum has to be greater, the perimeter has to be greater than 61. And now if we solve the inequality, we get x is equal to 9 centimeters. They have just asked the length of the shortest side, and this we have got as 9 centimeter. Let's see the last question. A man wants to cut 3 lengths from a single piece of board of length 91 centimeter. So it is very clear that the maximum length can be 91 centimeter. It is a 91 centimeter board from which there have to be 3 different boards. They will have to be separated from a larger board of 91 centimeter. So the overall length cannot be more than 91 centimeter. This is the first condition. The other thing is given as the second length is to be 3 centimeter longer than the shortest. This is another condition given. And the third length is to be twice as long as the shortest. So if we take the shortest as x, then the second board will be x plus 3. And the third board will be twice as long as the shortest. That means the third board will be 2x. And what are the possible lengths of the shortest board if the third piece is to be at least 5 centimeter longer than the second? So this is the first condition and this is the second. Let us see how we use it in the solution. So you have taken x as the shortest length of the shortest board, then the second board length of the second board is x plus 3, length of the third board is 2x. And we have seen that the combined length cannot be more than 91. It can be only less than or equal to 91. So if we solve this, we get the solution as x is less than equal to 22. That means the length of the shortest board has to be less than 22 centimeter. But this is not sufficient. There is another condition given. What are the possible lengths? What are the other possible lengths of the shortest board if the third piece is to be at least 5 centimeter longer than that? Now x is less than 22. There are so many possibilities, but they have given another condition which will also need to be satisfied. So for that we will write it as 2x is greater than equal to 2x is what? The length of the third board. They have mentioned that the third piece is to be at least 5 centimeter longer than the second. The second is x plus 3. The third is 2x. And it has to be at least 5 centimeter longer than the second board. So second board plus 5, and then we have on the LHS the length of the third board. So when this condition will be satisfied, then we get x is greater than equal to 8. So x has to be greater than equal to 8 and x has to be less than equal to 22. So the answer will be at least 8 centimeter. The shortest board will be at least 8 centimeter long, but not more than 22 centimeter long. So because of this second condition, the other solution has also appeared. Otherwise the question would have been only till this place, right? Now this part occurred just because of the second condition that was introduced. And so finally we have this answer, at least 8 centimeter and not more than 22 centimeter. So this is how we solve problems related to inequalities and also the word problems. So that's all for today.